This is part 2 of my series on learning the SQL database language. We'll be completing the practice exercises on the HackerEarth.com website. Once you navigate to the site, you can click on the search icon at the top and type SQL. Then you want to filter for problems or challenges. And as you scroll through the challenges and click on each one, you'll notice that they've already been completed. So for example, this particular challenge was done in 2016. That was for people that wanted to compete live. Even though it has ended, we can still complete the problems. We just won't be able to compete in the competition. So if I click on solve problems, you'll see a list of potential problems I can solve that are part of this challenge. But if you go back to the original list, you'll notice that each challenge has its own set of maybe 5 or 10 problems. So you'll want to go through each challenge one at a time and solve all of the problems inside each challenge. In addition, once you click on a specific problem, you'll want to scroll down to the bottom and pick the database engine that you want. So in this case, this particular problem can only be solved using the Oracle database engine. If that's not the engine you want to practice with, you should just skip this problem altogether and instead pick a different problem that supports the engine you want. In my case, I want to use Microsoft SQL Server 2019. And so this particular problem supports that. So this is a problem I might want to solve. And one thing to note, at the top, it says that the problem is not available for practice. That's actually incorrect. I'm not sure why the website says that, because right here it says the table is triangle and it has these columns. If I just really quickly do a select star from triangle and click execute and test, you'll notice that the query output a bunch of records from the database. So obviously it is working just fine. So ignore the fact that it says it's not working. So let's solve these problems. This first one says I have a table with 3 different sides to a triangle. And this person wants me to design a chimney which has the maximum area for a triangular shaped chimney. So this is the formula to how to calculate the area of a triangle. It says that I need to pick the maximum side from each of the columns and calculate the area. So if I look at these 2 rows, the maximum side is just going to be the largest of the 2. So in this case, side 1, the maximum is 7. But for side 2, I have these 2 choices, 6 and 17. So the maximum will be 17. And for side 3, the maximum will be 18. And then if I consider side 1 is A, side 2 is B, and side 3 is C, I need to calculate this S variable. And then after I have the S, I can plug it in with S, A, B, and C and calculate the area with that. And the answer is, in this particular case, is 59. So I don't really understand what this formula is accomplishing exactly, but I do know if I maximize each of these columns and plug them in, that I will get this answer. So let's just code it up. So first of all, I have a triangle table with these columns. So let's query that data. Select side 1, side 2, and side 3 from triangle. Now it has an ID column, but I don't need that in this case. In order to get the maximum from each column, I can just use the max keyword. So max is a function that's called an aggregate function. There are other types of aggregate functions, for example, min, AVG, which is average, sum, which will add up all the numbers, and count. Those are just a few examples. There are more. And essentially what they will do, I need to change to Microsoft SQL, and I just lost my code. Okay, switch back to MySQL, copy my code, and then Microsoft SQL Server and paste it. So what maximum will do is, because I'm querying the triangle table, then I'm referencing each row in that table almost like one at a time. The maximum will take the entire list, loop through them, and figure out which one is the largest and return just that one value. So where I originally had 2 rows, this will just return 1 row because it will just be the largest value. But it will mix and match the values. So for example, for side 1, it will give me the number 7, but for side 2, it will give me the number 17 because it's reading vertically through the entire column and getting the maximum value. So it doesn't have to all be from the same row. So let's just run this by itself and see if I get 7, 17, and 18. If I get different values, it could be that, so probably the example data they show at the top is not the actual data set that they run the test against. So it's probably fine in this situation that I got 12, 22, and 20. So if I wanted to give a variable name to this column, so for example, when I run maximum on side 1, it is no longer the column of side 1 because it's been modified. And it doesn't modify the real data, it's just modifying it on the fly as it shows it to the user. But it loses its name because once a formula has been executed on it, the data has been transformed. So I can alias it because without aliasing it, it has no name at all. So by using the as keyword, I can alias it and I could call it something like maximum side 1. And you can call it anything you want, just like a variable name can be anything you want, but you want it to be descriptive enough so that someone else reading your code is going to understand it, or even yourself in the future when you come back, that you might be able to understand it. Because if you just give it a random term that's not descriptive, like value, it's like, or number, that's too generic. So it might be hard later on to understand what it's doing. So I'll call it maximum side one. And actually, in their original formula, they called it A, B, and C. So I could also use that as A, as B, as C. And the as keyword is not required. If you just do space A, the as is implied. But I think it's better to still type it, even though it's not required, just so the code's more readable. Now, I need to add them together in order to calculate the S, but I still need to keep the original values because they need to be separated when I'm doing the final formula for area. So I think I'm actually going to use variables. In general, in SQL, it's better to just do everything in an actual query and not use variables as much as possible. Variables are more like traditional languages like C++, and the issue is variables only act on one value at a time, whereas something like a select statement runs off of an entire table which has multiple rows. And so databases are optimized for modifying a large amount of data at once. So once you get into variables, then it's no longer optimized for a large data set. But in this particular case, I think it'll be okay. So I'm going to make a variable called A and make it an integer, which means it cannot have decimals and it has to have numbers and the letters. And I won't give it a value yet. So normally if I put like equals 0 or equals 1, that would be like a default value. But instead of assigning it here, I'm going to say @A equals inside of this select. And then I don't need this alias on the column anymore. And I'll do the same with B and with C. You use the @ whenever you're defining a variable. So when you write your syntax this way, where the variable gets assigned inside of a select statement, your query can only return one row. So for example, if I did not have this max on here, triangle has 2 different rows in it, at least in the example up here. So this would be confusing because a variable can only have one value, just an integer in this case for the A variable. And by taking off the max, I'm now reading the value 7 and putting it into the letter A, the variable A, and afterwards reading the number 4 and putting it into the variable A. So since the variable can only hold one value, the 4 is going to overwrite the original 7. So the final value will be 4, but that's kind of like an error because it's trying to put 2 values in. So depending on the database engine, it may throw an error or you may just get unexpected results because you don't know which order the values are going to be assigned to the variable. But most likely it's going to be the very last value that's going to be assigned, and that's just not very useful. So if you're not going to do something like max to enforce that it only has one row, you could also use a command like top1 to make sure that only one row is returned. But I'll use the max keyword. So now after this query has been executed, each of my 3 variables should have the correct value. Then I just need to execute this formula. And I'm just going to copy and paste it so I don't have to retype it. So because s is a new variable, I'm going to use the declare command, and I'll use an @S. And because it's being divided, it could have a decimal. So instead of integer, I'm going to make it a numeric. And the first number, inside of parentheses, the first number tells it how many maximum digits can be in the number. So I'll just say something like 10. And then the second is how many decimals of precision. So I think I'll say 2. So because if you look at their original answer, they said 59.39. So they're doing 2 decimals of precision. So technically I could have used 4,2 because in this case there's 4 total numbers and there's 2 to the right of the decimal. But I just chose to do a higher number in case some of the examples they have when they execute tests happen to be larger numbers. So because I copied these formulas in, they are not in SQL form. So I just need to change these to SQL variables by putting an @ in front. And then this should work to calculate the S variable. And then I'll do the same thing for the area. And again, just put the @ in front of each variable. And semicolons at the end of each line are not necessarily required, but you can add them just to separate the different commands. It's up to you. And then afterwards, I just want to output the area that was calculated. Now, because this is a variable, it also does not have a column name, similar to how the max command modified the column, and so it lost its column name. Variables are not tables and not columns. They're just individual values. So I can still use them in a select, but I need to alias them if I want it to have an actual column name when it's output. And you'll notice that in this select statement, I don't have a from. I'm not reading from a table. I'm just reading directly from a variable. So in this case, there's only going to be one row. So let me just run this and see what happens. So I am getting an error here. I'm not exactly sure what the issue is. It says that so incorrect syntax means there's some kind of keyword or something that I typed. But what's weird is it says near and then it has empty quotes. I don't remember putting empty quotes in my code anywhere. And it doesn't exactly give me a line number either. Oh, I think I realized what I did wrong. On my variables, I'm missing the int. So I did not define my B and my C. So I can run it again and see if that fixes the error. But what I was going to say is, in a situation where you're not sure what you did wrong, what you could do is copy the whole thing and back it up just in Notepad or Word or something, and then just delete part of your code and run it and see if the error goes away, so that you can narrow down one line at a time to see which particular line of code is broken. And that's only when you don't have good error messages. Usually you're going to have better error messages that tell you the exact line of code. Now that I've typed this int, let me execute again and see if it fixes the issue. Okay, so it's a little bit better. It says I have to just define the variable a. So I did define it here. So I'm wondering if it's getting confused by my semicolons, because it's thinking that they are separate queries. I'm going to take all those off because it definitely was defined here, and so it should have worked here. Although I did notice with the area, in one case I've got an uppercase and somewhere else lowercase. It may not matter, but just for consistency's sake. Okay, so I've got a new error now. Now it says it doesn't like the equal sign. Again, I'm not sure which equal sign it's complaining about, but I'm going to assume it's this one with the select. So let me just cut out some of the code and re-execute to see. Okay, so in this case I did not get an error, but it just said my result was wrong. So that makes me think it was a different equal sign it didn't like. So let's see if it happens to be line 6. That's the issue. Okay, again, no issue. So maybe it's on the area equals. Okay, now that the error came up. So it must be on this line here. Let me make sure that my parentheses are all lined up right. So I've got this set of parentheses that look fine. These look fine. And these look fine. And then that square root. Oh, it makes sense now. Before my equal sign, I did not define the variable that area is using. So it should also be a numeric 10-2, I think. Let's try again. Okay, not only did it execute with no errors, but it gave me a green check mark, meaning I got the correct answer. So perfect. So just to recap, declare defines a variable. @ is a prefix you use anytime you use a variable name. Variables names should be letters, but they can be full words like area. They should not have like weird symbols or spaces in them. And then int and numeric are the data types, so the type of values that are allowed to be inside of that variable. And then we've already covered in a previous video the select and the from clause, so I won't go over that. But the equals allows me to assign a value to a variable as it's querying the data. The max is an aggregate function that's going to loop over all the rows and find the largest value in that column. And the star symbol in this case is doing multiplication. So in the case that you do select star, that asterisk means return all columns. But in a math formula, when you use a star or an asterisk, it does multiplication. And then at the end, you can do a query off of just a variable without a from keyword, and that will still execute and return the value of that variable as the final result of your query. So I do want to get into more details on aggregate functions like max, but rather than explaining it here, let's see if one of the next problems requires those. Because there are other keywords, for example, group by, that you'll commonly use along with aggregates, but we'll go over that hopefully in another example. Okay, next example. Okay, so it's given me a table of students, and within the table there are 3 columns: name, age, and height. And the problem basically says that there's going to be a sporting event at the university, and students are going to be picked at random to be on teams, and each team will have size 3. And because it's sports, then the height of the student is the indicator of how good they'll be at sports. It says if I sum all of the heights, that will tell me the strength of that team or group of students. And it says when I calculate the strength, I need to round it 2 decimal places. So in this case, this team has height of 2 for 3 different students. So if you sum that up, 2, 4, 6, the answer is 6, but it has 2 decimals. So this seems, again, I need to change to Microsoft SQL Server. This seems similar to the last one, but instead of the max keyword, I can use the sum keyword. So I really just need the height column from the student table. So this will return me, select height from student will return me 3 rows that say 2, 2, and 2. But I want to add them up, so I'm going to do sum. So then it'll only give me 1 row that has the value 6, but I want it to have 2 decimals, so I'm going to cast it. So the original height is an integer, so when it's summed up, it'll still be an integer. But if I cast it as a numeric, and it doesn't really matter what value I use on the left as long as it's big enough to handle, like in this case, 6.00 would be 3 total numbers. So for the example, I could use 3, but I'll just make it bigger just in case there are some really tall people. I guess if it's meters, really 3 is probably fine, but it doesn't hurt to make it larger. Anyways, and then I want 2 for the decimals. And it doesn't really matter what I call this column. I don't think it didn't tell me that. But again, the original was called the height. And now that all these formulas have modified it, it's no longer going to have a column name. So I'll just call it strength because that's what the problem said. It's like the strength of the team. So let me execute this. Okay, I didn't like my keyword student. That was supposed to be the table, and it looks like I just missed the S on the end. Students. Try again. Okay, I got the green check mark, so I got it right. Next problem. Okay, this problem is actually kind of challenging, so we'll break it up into smaller parts. So essentially, I have a table called first, which stands for the first semester. So each semester you have students that take classes in certain subjects, and marks is what kind of grades they got. So I assume the higher the number, since it's an integer, the higher the number, the better. And for the second semester, it's similar, where you have subjects, but instead of tracking the marks or like what grades they got, it's tracking tests. This is actually a true or false, so they really should have used a bit column, but it's text and they use the word yes or no to say whether or not they took a test in that subject. And in particular, it says that in the first semester table, if it's the student's favorite subject, they also get the best grades in their favorite subject. So the problem I'm supposed to solve is by taking a list of students in 2 different semesters. So I could match up the students based on the ID. So ID 1 here, the student's name is A, and in the first table. So if I take the second table and match up ID 1, it's, even though this does not say the student's name, so the subject is Hindi, I can join these 2 up because they have the ID of 1. That means it's the same student. So student A got a score of 205 in math and 30 in English. So their favorite subject is math. But then within ID 1, which is also student A, they took a test in Hindi, and so these subjects are actually lectures that they attended. So they attended 2 lectures in math, but only one had a test and one did not have a test, the other did. So what the assignment is to figure out which students have attended at least 2 lectures with a test in their favorite subject. So for example, student A, their favorite subject is math, and they did have 2 lectures in math, but only one had a test, so they would not be considered an exceptional student. Student 2 is named B. Their favorite subject is Hindi because they had a higher score of 70 compared to 50 in science. So Hindi is their favorite subject, and within ID 2, they took Hindi lectures twice, and both times it had a test, so they would be considered an exceptional student. But the ID was 2, but the name was B, and in the output you see that it's supposed to show the name B. And then C, since they only have 1 class, it's automatically the favorite, which is Hindi. And then they also had 2 Hindi lectures, which each had a test, so they would be an exceptional student. And I noticed this is a little odd, but the second table wasn't really sorted, so student 1 actually had an additional math lecture, but because it was not tested, they're still not considered an exceptional student. So let's break this up into smaller pieces. So first, I'm just going to get my data out of my 2 tables. Right now it's 2 separate queries, but I'm going to modify that in a second. I'm probably actually going to join them together. But let me think of what columns I need. So I am going to need the ID column from both so that I can join them. I'm going to need the student column from the first because that's what's going to be output, is the student name. I'm also going to need to join not only on the ID to see if it's to match up the student, but also on the subject, because in this case where student 1 had 2 subjects, math and English, because English is not their favorite subject, that does not matter. So I will need the subject from both. I guess I really need everything because marks determines if it's the favorite subject, and I need to know how many tests were taken. So I think in this case, I'm actually going to write 2 separate queries to solve each half of the problem, and then I'll join the 2 together. So let me type everything up, how I would solve it, and then I'll explain it as I go. So I'm going to say with favorite subjects as, and I'll say select, inside of parentheses, select student's name and their ID and the subject. Okay, so I don't need to actually return the marks because I'm only going to be returning the favorite class, which is the highest mark. First of all, the subject here, because it's highlighted in blue, and also first because it's highlighted in blue, that means those are keywords that are part of the SQL language. In this case, it should work just fine, but anytime there's a word highlighted in blue that's really just a column or a table, I wrap it in square brackets, and that just removes the coloring because it tells SQL that I'm not trying to use an SQL keyword, I'm just trying to use like a column name or a table name. That's not always required unless it actually gets an error because it can't understand your code, but I choose to do that anyways. And then next I'm going to use a different aggregate function called row number. Okay, so let's break this down. The entire query is not yet written, but I'll just show the first part of it. So the with keyword creates something called a common table expression, and a lot of times that's abbreviated as a CTE, but another similar concept is basically a subquery. So what this means is this query it's considered a subquery because I can use it in an outer query. So I've essentially got 2 separate select statements, but as a whole, it's executed as if it's one single query. So it doesn't execute this one and then afterwards execute this one. It actually executes the whole thing. So in essence, what it's actually doing is it's doing a cut and paste. It's taking the inner part and it's replacing where the table name is aliased, and basically wrapping it in parentheses. So this is another way that you could write it. So I'll write it in both ways. These two queries are actually identical. There's no difference between them other than just the way that they are read. But I prefer the CTE version, the common table expression. I think it's slightly more readable, in particular when you have multiple subqueries, because we will afterwards want one that's based on like the number of tests that a student took. And so I could put a second subquery here, and then I could join to tests afterwards. And I have not yet explained joins yet, but I will in a second. But I like this CTE way slightly better because I can have multiple subqueries, comma separated, and then afterwards have my final query. Whereas this other way, the code just kind of becomes more jumbled, because if I were to do a join instead with tests in the second way, the second query would go in parentheses. So I think second was the name of the second semester where the tests are taken. So in this case, I have two separate subqueries that are mixed in with my joins and my outer select. Whereas with the CTE way, each of the inner queries are written on their own, and then you have a final query. So I just like that in the final query, everything's very readable, whereas in the bottom one, everything just becomes more jumbled. So that's why I prefer the CTE way, but either one technically works. So if we just look at the subquery, what it's doing is it's taking the first semester table and it's returning the ID of the student, the name of the student, and the subject. So in the case of student A, they have two subjects, both math and English. And so it's going to return two separate rows for student A. What this row number does is actually, let me copy and paste the number so I can show you. Okay, so if I have another column here called row number, then the partition by first is going to essentially group based on the student column. So student A is going to be considered his own section. Student B is separated as well, and then student C. So it's kind of like three separate buckets, one for each. And then within that bucket, it's going to do a sort based on the marks column, but it's going to be doing a descending order. So within student A, it's going to look at the marks. So math is 205, which is the largest. English is 30, which is the smallest. So it's going to sort descending. So in this case, it's already sorted in that order. But for student B, it's in the wrong order. So it's going to swap the order here so that Hindi is on top because it's the higher value. And then this one, since there's only one row, the sort doesn't matter. It's already in the proper order. So then afterwards, it's going to assign a value to the row number. So it's going to go 1, 2, and then it would keep going as 3, 4, except that these are in separate buckets. So because we partitioned by student and it put student B in a separate bucket, instead of keeping going with 3, 4, it's going to start over 1, 2. And then again with student C, it's going to start over again at row number 1. So the value of the row number, it's actually extremely useful. I use it all the time. The value is that I can now use a where clause off of this row number to look for the number 1. And I know that number 1 is essentially the highest value for each student, which is essentially their favorite subject. So I called this subquery favorite subjects, but technically I don't yet have a where clause on this row number. So it is not yet only their favorite subject. It's just their subjects sorted in descending order. So ideally what I would want to do is I would want to take this row number and move it down to a where clause and say equals 1. The problem with that is for some reason, SQL Server does not allow you to use aggregate functions. So row number is an example of an aggregate, but others are average, max, sum, count. And an aggregate is essentially anything that takes a group of rows and calculates some kind of value by looking at the group of rows. And so those are not allowed to be inside of a where clause. However, once it's a subquery, you can trick it into allowing you to put it into a where clause. So the way I would do that is I'll make an additional subquery called favorite subjects. And that's why I'm going to rename my original to just say, I guess, classes. So inside of favorite subjects, I can reference my classes subquery as if it was a table. So I'll say select star from classes where, now I need to give this row number a column name because otherwise I can't reference it in the where clause if it doesn't have a name. And because row number is a calculation, then it's a combination of both the student column and the marks column. So it doesn't keep either of those column names once the data has been transformed. So I'll just call it row num. And I'll just reformat this a little since it was wrapping the text down to the next line. So because I gave it the name of row num, I can say where row num equals 1. So I have a classes subquery and the favorite subject subquery references that classes subquery. And it does a filter off of the row num column. And because it's checking for row number 1, then for student A, math will be kept because it's the favorite subject, but English will be removed because it's not the favorite subject. And for student B, Hindi will be kept because it's the favorite subject. Science will be removed because row number is 2, not 1. So that one will be removed, and student C will keep Hindi. So now I have the 3 rows which are my favorite subjects. So next I need to know how many tests each student took in the second semester for each class. Now I could do it just based on favorite subjects, but instead I'm just going to do it on all subjects. So I'll do select count. Now count is an odd aggregate function. In this case, I'm going to say that I'm going to count the subject column, but in reality, it does not matter most of the time which column you count, and I'll explain why in a second. And I put brackets around it. Those are not normally required, so you just use parentheses when you call a function. And so what goes inside the parentheses is the parameter that's passed in to your function. But because it's highlighted in blue, it's like SQL thinks it's a keyword. And so that's why I put brackets around it. So the brackets are not really related to count. They're just to make subject not highlighted. So I guess I'll leave the brackets out just so that it doesn't look confusing. Okay, so the count will be as, I'll alias it as the number of tests. So the table I want to read this from is going to be second, and because it's highlighted in blue, I'll put brackets around it, and I'll say where test equals yes. So the test column, if it says no, I don't really care that they went to the math lecture if it was not tested, because I actually need, I only need to count up the ones that are tested. And then I'm going to say group by student. Actually, student is not in this table, it's only ID. So I'll group by the student ID. So let's grab the data from the second table and show what this is accomplishing. So just like we did partition by before, group by is identical. The reason the keyword is different, partition by or group by, is one is used directly inside of the aggregate function on the same line as you're declaring the column, and it only affects that one aggregate column, whereas group by affects the entire query and all of the aggregates. So for example, if I was doing a sum and a count and an average all at the same time on the second table, so the second semester, this group by would affect count, sum, and average. Whereas if I wanted each of them to have their own group by, then that's when you use the partition by command. And each of these can technically have their own partition by. If you use group by, all of them have to use that same column, and you can do multiple columns, but the group by is what determines the buckets that they're grouped into, and partition by does the same thing. But with group by, it affects all of the columns. With partition by, you can do a separate arrangement of buckets for each column. So I technically could use either one since they both essentially do the same thing, but just to show both versions, I'll do group by in this case. So because I'm grouping by the ID, which is the student ID, the count will be based on those buckets. So if I look at the second semester table, first I'm going to separate ID1 into its bucket, then I'll do ID2 into its own bucket, then ID3 into its own bucket, and notice that there's an extra ID1 row here at the bottom, so that needs to go in the first bucket. So this will get moved up here. So I've got 4 in this first bucket. Now, the reason it doesn't matter which column I'm counting, if you're doing a sum, it would matter, right? Because sum is adding the numbers. So, you know, if I did a sum of the ID column, 2 plus 2 equals 4, but you can't even add text together. Like yes plus yes doesn't mean anything. And if I had a separate column, which was there, for example, with marks, which was in the first table, you know, a sum would take 205 and add to it 70. But count, it's not doing any math. It's not adding the values together. It's just counting the rows. So in the case of student ID1, it'd be 1, 2, 3, 4. So whether I count Hindi, math, 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 or if I count 1, 1, 1, 1, in either case, it's the value 4. So in general, it doesn't matter what column you pass into count. So I actually, a lot of times, don't even do a column at all. I do just a static value of 1, kind of to say it doesn't matter what I'm counting, because it's really just counting rows. The one caveat where it could matter is if you have a null value, which is essentially the absence of a value, then nulls do not get counted. So in this case, if this was some other column called ASDF, and that's what I was counting, nulls would get skipped. So instead of being 4 rows, it would only be 2 rows. And the other caveat would be, if for some reason I don't want math to get counted twice, or 3 times in this case, so I just want Hindi and math, if I just wanted this to be a count of 2, because math, I didn't want to count the duplicates, then I could count the subject column, and I could put the word distinct before the subject column. And that would say, ignore the duplicates. So math would only be counted once. Now, because it's grouped by the ID, even though Hindi was used by the first student with the distinct, the second group bucket, which is student ID 2, it can start over counting again and ignore the distinct. So it's not going to care that student ID 1 had a Hindi class. It's just going to care that student ID 2 has a Hindi class. And because I have the distinct, it would only count it once here. And for student ID 3, it would only count it once. But in our particular case, we don't need the distinct and we don't have to worry about nulls in our case. So I think I will just do the count 1, just kind of say it doesn't matter what I'm counting. However, I don't actually want student ID 1 to count 4. I really just want it to count the times that it took a test. And in addition, I don't want to combine math and Hindi into the same count, because even though I took 2 total tests as student ID 1, they were in different subjects, and I want to know how many tests were on the subject of Hindi and how many tests were on the subject of math. So I'm actually going to modify my group by to include the course or subject as part of the separation of buckets. So that way, Hindi and student ID 1 gets its bucket, math and student ID gets its bucket, and then Hindi and student ID 2 and Hindi and student ID 3. So it gives me an additional bucket. So then in this case, the count will be 1. In this case, the count will be 3, and then 2 and 2. And then finally, in the case of math, since these tests were not taken, I don't want to count them. So instead of getting 3 for math, I actually only want to get 1 for math. So that's why I say where test equals yes. Now, finally, you can, I mentioned with a where clause that an aggregate cannot be inside of a where clause. However, you can do a second where clause after the aggregate is done, and the keyword is called having. So I can say having count of 1 equals 2, because I want to know which subjects had 2 tests, or technically I'll say greater than or equal, because if they had 3 tests, that also will work. So, and I think I could have actually done that here with the row number. Let me try that. So I'll say having row num equals 1, and then I could actually rename this classes to favorite subjects and get rid of the second subquery. So you can only have one having and one where, I believe, but the having executes after the aggregate is calculated, and the where executes before the aggregate is calculated. So I said earlier that I didn't know why you couldn't put row number in the where clause, and I guess that's the reason why. It's because of the order of operations. The where happens before the select, and so the row number would not be calculated yet, and that's why you can't put it in the where, whereas the having happens after the select. So that's why why aggregates cannot be in the where clause. Okay, and then rather than, this is fine that I said count greater than or equal to 2, but it's better to give it a column name, and so rather than copying and pasting your formula, you can just use the column name. Technically, it's not doing any extra calculations because it's not going to actually execute the count function twice. It'll realize it's the same formula and only execute it once. But in case you ever change your formula, or if your formula is really long, then it's better just to use the column name. Okay, so then rather than just calling it tests, technically this is subjects that have 2 tests. So maybe I'll just rename it to 2 tests. So I don't need this example data at the top anymore. But now that I have my 2 subqueries, I need to combine them together, and I'm going to use the join clause for that. And I forgot, along with the number of tests, I need to know which student it was, and I need to know which subject was for. Now, something to note with the group by command that is different than the partition by command is the partition by, because it only affects the one column, the one aggregate function, you can partition by anything you want, and the other select columns are not affected by your partition by. But in the case of group by, you cannot have any additional columns in your select that are not in your group by. You can have missing ones in your select. So I could remove subject off the select if I wanted to, but I could not add the test column to the select if it's not grouped. So if I add test to the select, I have to also add it to the group. And that's because since the group by is creating the buckets, then if my buckets are ID and subject, it would not make sense to have values that are unrelated to my bucket show up next to the aggregate of that bucket, because the data wouldn't make sense. So in the case of partition by, it actually can create data that does not make sense, but since you're kind of more in control, it's your job to figure out how to make that work. So for example, let's say I had like a city and a population and a country. Las Vegas is inside of Nevada, which is inside of USA. But there are going to be other cities inside of Nevada, and there are going to be other states inside of USA. So if you're grouping by the state and summing up the population, then that would mean you would take all the cities in Nevada, add all of their populations up, and that would be like a subtotal of Nevada. But it does not make sense to also put the country next to it because the country was not involved in creating that bucket of population. So you need to also group by the country. In the case of country, it doesn't seem too wrong because Nevada is inside of USA, but think about going the opposite direction. If you did city, then, I'm grouped by the state, which is Nevada, and I'm adding up every single city in Nevada and getting the total population. If I also show the city, then the final result would say something like Nevada, 1 million people, and then Las Vegas. Well, this million didn't only come from Vegas. It also came from other cities like Reno. And so it doesn't make sense to show the city because that was one of the multiple items that were added up together. So that's why the group by needs to match the select. So if I'm going to show city in the select, I have to also put in the group by. In the case of partition by, if instead I did sum population over partition by state. So if I do a partition by, I don't need a group by, but I could, if I wanted, have two separate summed populations, one by the country and one by the state. And so these are actually doing two separate calculations here. So in this case, this would be like, total per state. This is total per country. So maybe it would show Nevada, if I put the state here, next to 1 million. I don't actually know how many people are in Nevada, but I'm just guessing. And then next to that, it would show the USA population, which is probably like 300 million. And so with the partition by, you can do that if you want. And it may create data that doesn't make sense because Nevada is not actually 300 million. Nevada is 1 million. So it's up to you to make sure you name your columns appropriately so that you clarify that this 300 million is for USA and this 1 million is for Nevada. So that's one difference between group by and partition by. So partition by is a little bit more powerful and it gives you more options. Okay, so I have my favorite subjects. I've got my row number and my halving so that it filters out any subjects that are not my favorite. And then I've got separately all the classes that I took a test in and grouped by the student ID and the subject. And then I have a count with a halving. Now, I don't actually need to return the count, I just realized, because the only reason I need the count is just so that I can check if it's greater than or equal to 2. So I can move it out of my select because the select is what's actually going to be output to the screen. Or in this case, since it's a subquery, subquery is kind of like a temporary table in memory. And so like that value would be calculated and kept in memory so that later on when the rest of the query is running, then that value is available. But I don't actually need it to be returned by the subquery. I just need to use it to calculate if it is greater than or equal to 2. And I think the same is actually true of the row number. I just need to know if it's the first row. I don't necessarily need to return that value. So I think that will still work. If it doesn't, I'll undo those couple of changes there. But anyways, now I have my two subqueries. So normally when you're writing a select from, you put a table name. In this case, I'm writing my subquery name. And then with a join, you have multiple types of joins. You have an inner join and an outer join and a cross join. And then within an outer join, you can do left and right. Now, I would just ignore the right because left and right is almost essentially the same thing. So to explain joins, let me copy the first semester table and paste the data down here. And then let me also take the second semester data and paste it as well. And just to simplify it, I'll remove a few of the rows. So I'll keep 2 rows from student 1 and just 1 row from student 3. And then I'll do, on the other table, I'll do 1 of student 1, 2 of student 2, and 1 of 3. So let's talk about the cross join first. What a cross join does is it will take the very first row and match it one at a time against each of the other 2 rows. So it's combining 2 separate tables together into one giant table. And so this first row becomes 3 rows. The second row also becomes 3 rows because it's going to match against that same list. This third row also becomes 3, and this fourth row also becomes 3. So 4 rows multiplied by 3 rows is 12 total rows. And another name for cross join is a Cartesian product. So let me paste what the results would be. So my columns are going to show 2 times. On the left is all my first set of columns, and on the right is my second set of columns. And then this first row is going to get pasted next to each one. And then the second and third rows will also get pasted. So here's my original set of rows 4 times. So on the first 4 rows of the original table, the second row got pasted next to it. And then for the 4th row, then all 3 rows from the second table will get pasted next to it. So this is a cross join. And an inner join and an outer join are similar, but they have slight differences. So you're probably wondering, what is the value of a cross join? Well, you're typically always going to do a where clause afterwards. So if I have all of this data, the data that makes the most sense in this situation is when the IDs match up, because the IDs are the student's ID. So on the right side, student ID 1 took a Hindi lecture and also took a test. And then on the left side, student ID 1 has a name of A. They took a course in the first semester on math and they scored a 205. So combining these records together makes sense because they're for the same student. However, it doesn't completely make sense to combine these two records together because one is for math and one is for Hindi. So your where clause is going to determine which rows of these you keep and which ones you filter out. It depends on the specific logic that you're trying to achieve with the specific business rules and that you're being asked for in the report that you're writing. But in our specific situation, we're looking for a favorite subject to match up with two lectures that each had a test in that same subject. So after we do our cross join, we would want a where clause to match up the student IDs and also to match up the subject. And in our case, we've actually already filtered out to only favorite subjects and to only courses that had two tests. Whereas when I did this cross join, I didn't run those initial filters. I just picked a few random rows of each. But let's just pretend that I did this where clause. So on the left, this table would be the favorite subject table or subquery. And on the right, this would be the tests subquery. Now I can alias this to make it shorter. So I'll say as F for favorite subject and as T for tests. So in my where clause, I can say f.id equals t.id. And that will match up these ID values. And if they're not equal, because I required them to be equal in my filter. So if they're not equal, they'll get removed. So this one is ID 2 matched up with ID 1. So it'll be removed. Same thing here, same thing here, same thing here. So this would be the final result of checking for the IDs to be equal. And then if I also required the subjects to be equal, f.subject equals t.subject, then it would also filter out this top row. So the cross join by itself creates way too many rows that don't match up, but then the where clause filters it so that you have only the rows that match up together. And the reason we put an alias on favorite subjects or tests is because the two column names are identical. So without the prefix, if you just say ID equals ID, SQL Server doesn't know which table each of those columns are in. So it's ambiguous and it gets confused. So you need to give it a prefix. But you could, instead of using an alias, put in the full table name, but it gets annoying to have to type such a long name over and over again. So that's why you typically will alias it with just the first letter of the table name. And if you end up with multiple tables that start with the same letter, then you might do something like for favorite subjects, I would use the first letter of the second word as well. So FS instead of just F. So that's the cross join, but inner join and left outer join are similar. Let me get the original data back. So I'm going to comment out the cross and the where, and instead I'll do the inner join. So a comment just means don't execute this code. So that can be used to remove code from being executed, or it could also be used to write a note to yourself, like note, this is a cross join. So maybe if you're doing something a little weird that you might not remember or understand later, you might write yourself a note. So with an inner join, it's doing the exact same thing as this cross combined with this where. The difference is that the inner join requires you to give it a filter. The cross join does not have to have a filter. So if I actually wanted to keep all 12 of these rows, I could do that with the cross join because the where command is a completely separate command from cross join. Inner join, it is required to have an on keyword afterwards. So I would say, so up here at the top, I did favorite subjects join tests. If I don't say the word inner, it's automatically implied if I just say the word join that it's an inner join. But I'll say inner join tests, and I guess I'll start with I'll write the code up here at the top. Inner join tests on, and then I'll copy this where clause into the on. So I can still have a separate where clause that does something else, like where, favorite subject equals maths or something like that. But the on clause is essentially an additional where clause that gets executed early. And the reason that's valuable is you may have like 3 different inner joins to, different tables like courses and teachers. And your where clause, if you were to use cross joins, then each of the cross joins will get exponentially more and more records created. And then your where clause will become very complicated because you'll have a filter for the tests cross join in your where clause. And you'll also have a filter for the courses cross-join anywhere clause, and also for the teachers cross-join anywhere clause. So that where clause will become very complicated. The benefit to the on clause is it's the same as a where clause, but it's filtered early. So when the join to tests happen, instead of getting 12 rows, it's going to immediately filter it down to the smaller subset of rows based on your criteria. And then when you join again to courses with a cross join, it would exponentially create you a bunch of rows. But by doing the inner join, since you would have to have an on clause afterwards, which filters it, it's not going to create nearly as many rows. And from an efficiency standpoint, the fewer rows you're working with in each iteration of joins, the quicker the query can be executed. So, and also it makes it easier to read. So for now, I'm just going to join to the one table, but I'll use the on clause, which is essentially the same as a where clause, and I'll filter based on that same criteria. So just like before, it's going to check for the ID to equal the ID, and the subject will also need to equal the subject. So in this case, math and Hindi don't match, so this row would be excluded. And then these would be excluded because the IDs don't match. This would be kept because both ID and math matches. These would be excluded because the IDs don't match. And this would be kept because the ID and subject matches. So you'd be left with just these two rows. So the only difference with an outer join, and I mentioned that you have a right outer join and a left outer join. The reason I suggest to just ignore the right outer join altogether is because you can easily convert between left and right. So what it means by left or right is simply the order that the subqueries or tables are joined in. So I forgot the word join here. Just like before, the word inner or the word outer is not required because all left joins are also left outer joins. They mean the same thing. And all right joins are also right outer joins because they mean the same thing. So you can just say left join or just say right join. So when you're doing a join, if you say left, essentially this table favorite subjects is on the left and the tests table is on the right. Because if you were to put it as one sentence, then as you're reading left to right, favorite subjects is on the left and tests is on the right. I haven't explained what it means to be on the left or right, but I mentioned that you can easily convert from one to the other. So if I wanted to make an equivalent right join, all I would have to do is take favorite subjects and move it to the right and take tests and move it to the left. And now I've converted from a left join to a right join simply by changing the order of my tables. And because of that, I just think it's easier in my brain to always think about left joins and just forget that right joins ever exist. And if I ever want to do a right join, I'll just swap the order of my tables and make it a left join. It's just easier for me to think about it that way. But I'll explain both versions just so you understand. So what a left join or a right join means is instead of deleting the row out of memory when it's checking if they match, instead it's going to essentially do like a comment in memory to just exclude the row temporarily. So in this, it's still going to use the same criteria, ID equals ID and subject equals subject. So this row would be commented out because it has a different subject, math versus Hindi. This row commented out because different IDs. This one would be kept because it's the same ID and the same subject. These commented out because the IDs don't match. And this kept because the subject and the ID matches. Now the reason I mentioned that it's being commented out is because what the outer join does is after it's done that preliminary filter, it's going to relook over the rows that are kept. And if there's any IDs from the original table that were excluded, completely excluded, it will add them back in with nulls for the other table because it couldn't find a match. So as an example, because it's a left join, it means kind of like the primary table in the join is the favorite subject. So it's saying I want to always keep favorite subject regardless. And then I want to try to match it up with tests. But if I can't match it, I still want to keep favorite subjects. I just want to give a null for the tests. So in this case, the ID of 2 got completely excluded because it was in favorite subjects, but it was not in tests. So instead of it being completely excluded, this row here of 2 science 50 would be kept, but then on the right side would be nulls. And the same would be true for, so it's not just based on the ID, but essentially every row that was in favorite subjects is going to be kept if it can't find a match. So this first row, 1A Math 205, it was kept because it matched up with tests. So it doesn't need to null out the test because it found a match. This 2B Science is the one that needed to have nulls with it because it could not find a match. This 2B Hindi also needs to be kept, but with nulls. 3C Hindi 40, that did find a match down here at the bottom with 3 Hindi yes on the test. So it does not need to copy this and null it out. And that's all of the original rows that were in the favorite subject table, because everything after that is just a copy of, so these 4 rows are a copy of the original 4, and these 4 were a copy of the original 4. The difference was, since I originally did a cross join, then the first 4 were matched up with the first row of tests, the second 4 were matched up with the second row of tests, and then the third row of test. So the left join allowed me to keep these 2 rows rather than completely filtering them out. But because it didn't find a match in the test table, it shows all nulls for the test table. So a right join would be identical to that, except the primary table would be the test table because it's on the right. So that would be the rows we don't want to lose. And the ones that could be nulled out if they don't match would be the favorite subject. So if I put my cross join results back here, and then I run my filter, the same rows are going to be commented out. So I only have these 2 rows, but that's just the preliminary filtering. But then it's going to decide which rows from the right table were completely excluded, and it's going to keep one copy of it with all nulls on the left. So in this case, the one Hindi yes was excluded completely. So it needs to keep a copy of the one Hindi yes with nulls on the left table. But the one maths no, that did find a match, and the 3 Hindi yes did find a match. So the other 2 rows in the test table, because they found a match, they don't need to keep a copy with the nulls. So that's the way an outer join works. And then there is also one called a full outer join, or a full join. And it essentially does what both the left and right outer joins do together. So if I paste my original cross join back in, and then I run my preliminary filtering criteria to comment out the ones that don't match, then I'll check everything on the left to see if it was completely excluded. So I have these first 4 rows on the left I need to think about. So if we remember, the original left table looked like this without the comments, and the original right table looked like this without any of those comments. So if any one of these rows is not returned because it's the left table, it would keep it but put nulls on the right. And if any of these rows didn't match, which are the right table, it would keep it but put nulls on the left, because the full outer join is doing both a left and a right outer join. So I only have these 2 rows that were kept, which means since I originally had 4 on the left table, there are 2 that are missing. So it's the 2B science and the 2B Hindi. So it's going to keep a copy of each of these with all nulls on the right. So that's the left outer join portion. And then on the right table, I had 3 rows, and the one maths no did find a match. The 3 Hindi yes also found a match, but the 1 Hindi yes did not find a match. So I would keep that 1 Hindi yes on the right side and put all nulls on the left side. So that's a full outer join. The most common ones that you're going to use are just join, which really means inner join. And then also you'll use left join, which really means left outer join. There's really not a reason to use cross join very often at all. That might be something you use like once a year, whereas the regular join and left join you'll use like 50 times a day. And then the full outer join, you'll use that one once in a while, but it's probably more like 1 time a month rather than 20 times a day like these other 2 joins. And the right join, which really means right outer join, you could use that just as often as the left join if you wanted, but because it's really easy to rewrite a right join into a left join, I think it's just easier to forget right join exists and just always write it as a left join. So if I convert this back to just a regular join or an inner join, I think this query is all written, and I think it does the logic that I was asked to do. Since this subject keyword is blue, I'm just going to put brackets around it. So let me execute this and see if it's happy. Okay, I got an error, and it says first.student is invalid in the having clause because it's not in an aggregate or group by. Having only works with group by, but does not work with partition by. And row number cannot be used with a group by. So instead of doing this having row number equals 1, I'm just going to move it to the where clause. Now I can't put it in the where clause of this subquery. I have to move it to the where clause of this outer query. And because I'm joining 2 tables, it's best to put f dot on the row number that I'm filtering. Technically, it will figure out which of the 2 subqueries it exists in because the row number column does not exist in the tests subquery. But just for readability's sake, I'll put the f dot in front. And then I think that this second subquery, using its having, I think it does work because it uses a group by, whereas the other uses a partition by. So I can probably even remove it back out of the select, but let me try it. Okay, so it doesn't like it with this num tests being referenced in the having clause. Let's see if I just paste the count 1 in the having clause. So it did still give me an error, but it's a different error. It's saying it doesn't like this join because I called it tests and the subquery is called toTests. So I'll fix that. So it looks like this did work. I'm able to do the having with an aggregate. And because I don't actually need that aggregate returned, I don't need to put in the select. And because this other one was using a partition by, I wasn't able to put it in the having. And so I did have to return it in the select. Even though the final result doesn't need it, I need it for this bottom query so that I can do the filter. And so I really should not use an asterisk here because that's going to return this row number, which the original assignment did not ask for that to be output. It said the sample output should just be the name. So that would be f.student. And because they called their column names, I should do the same thing. So let's execute it again. Okay, I got a green check mark, which means it's working. So essentially, this is the query that solves this problem. Now, this is a very complicated query, and I wasn't planning to get into an assignment this complicated yet, but that's just the assignment that this tool gave me. But we learned a lot of good concepts here. So I'm just going to do a quick recap to make sure it all makes sense. So the original assignment was to take the first semester table and the second semester table, and to, in the first table, figure out what the favorite subjects were for each student based on which one had the higher marks. So for student 1, math had the higher marks, so that's their favorite class. And then with the second table, we were supposed to figure out which lectures each student took that had a test, and in addition, which students had 2 lectures in that same subject. So in this case, student 3 had Hindi with 2 different lectures, and student 2 also had Hindi with 2 lectures, but student 1 did not. And then finally, the assignment was to match these 2 together and figure out which student had 2 lectures with a test in their favorite subject. So even though student 3 and student 2 both had 2 lectures in Hindi, that may not necessarily be their favorite subject. So for example, student 3, that is their favorite subject. Actually, both student 2 and student 3, it's their favorite subject because in the case of student 2, Hindi, it's a higher value than science. It's 70 instead of 50. And so because of that, students B and C were output, which are the names of student 2 and 3. So that was the requirements. So let's just go over again how we coded it. The with keyword is a common table expression, or CTE, which allows us to make a list of subqueries that can be used in the final query. And that allows us to break up our logic into smaller chunks and then use each of the small pieces together in the final query. So we wrote the favorite subjects query by querying the first semester table, returning the ID, the student name, and the class name, as well as by ordering the rank of their classes based on the highest mark, because it's descending order, but doing a separate bucket for each student. So that student 1 can determine its highest mark class separately from student 2's highest mark class. And once we've determined that row number, we're filtering for the first row number, which ensures that we're only getting the favorite subject. And then for the second subquery, we're taking the second semester, we're returning the student's ID and the subject. We're filtering for only courses that had a test or lectures that had a test. And then we're grouping by the student ID and the subject. And the group by will allow our aggregate to create separate buckets for these categories. So the combination of the student and the subject creates a bucket. So we can get a count for student 1 with math, and a separate count for student 1 with science, and a separate count for student 2 with Hindi, and a separate count for student 2 with math. And we're returning any subject where the student had 2 tests with that subject or more. Then after we've created both of these subqueries with those pieces of logic, we're joining the 2 tables together based on the IDs matching and based on the subjects matching. So the join will make every possible combination of favorite subjects with subjects that had 2 tests, but initially that join is not going to match up the right students or the right subjects because it's every combination. So the on clause is going to filter out the combinations that don't match our criteria. So if the IDs match and the subject match, it's going to keep them, and the other combinations will be excluded. So after the join and on have finished executing, then we'll have a list of only the students who had 2 tests in their favorite subject. And then we're just going to return the names at the end. So we've covered a lot of new keywords here, and I don't want to overwhelm you or make this video too long. So I think I'll stop here, and then I'll go on to other keywords in the next video. Thanks for watching, and let me know what questions you have about SQL that I can answer.